Welcome back to another episode of Freeform AI. My name is Michael Burke, and I do data engineering and machine learning at Databricks. I'm joined by my co-host. His name is
Wilson. I work on making agentic systems sound like humans in document generation at Databricks.
Yeah, actually on that, do you think we're just going to have AIs talking to AIs over email/Slack? Is that what the future is holding for us?
That's actually hilarious. Potentially. I think so. Yeah, you've used, I don't know if you've used it, but the first version of that thing that I launched, it's kind of hot garbage, right? It was meant to get the plumbing working, and the plumbing was most of the work there. And there was lots of decisions that were made under time duress that were like, I know this is bad, and it it kind of pains me to launch this like this, but I'm out of time. We got to just get this working. And then, a couple dozen PRs later of cleaning it up, making it resemble something that's like, okay, I feel comfortable modifying this now again and adding bolting new features on. But the feature that I'm doing now is like, hey, just have an agent that'll actually pull your sent emails and give it a structure of what you want it to actually extract from that. And it's the JSON's actually fairly large, but it's like a lot of, and it's specific to email, but it's a lot of categories of just human speech. Like, how do we convey ideas through language in the written form in this particular modal of
For
hey,
context,
email.
this is an email generator. It basically analyzes your emails, gets your tone, and then allows you to basically create draft emails for your review for responses to customers or whatever.
Yeah. And the things that are feeding it in are basically content from product pitch decks and docs and things that are written in a very specific form of tone. They're like, hey, these are the information that is contained within this that we're looking up answers to the customer's questions. That's all from a convincing tone of this is why our product is so much better, and here's a bulleted list of 100 reasons why. Well, if you just tell an agent hey, condense this into an email, it's going to be like, okay, I'll draft an email that contains all of these talking points. So it's just this massive list of code snippets and bullet points, and it's just preachy. And of course, that's the biggest feedback that people gave. I have to rewrite a bunch of this because it doesn't sound like I wrote it. So this project I'm working on now for the last week and a half is, how the hell do I get this so that it can even understand how I speak? So pull my sent items, classify how I conduct speech, and it pulls out this massive payload of this is how you talk to the world in this medium. And then I took it and just created another agent. It's the style formatter. And it's preserve the content here of the technical information, but write it with this style guideline. And it generated it. I'm like, oh my God. This is exactly how I would answer this question. Almost precisely.
Yeah.
And it lets you know that we're not as unique in that information distilling layer of written language as we'd assume. There are a little idiosyncratic tendencies that we all have about tone and phrase, and do we interject a little bit of humor? Is it deadpan? Is it kind? Is it funny? Is it authoritative? So with all of those properties, putting that to an LLM, that's its medium, is tone and style and linguistics. So it can understand those and generate a persona pretty convincingly. But of course, you know me, Michael. When I'm going to build some crazy shit, I'm not going to just be like, hey, make it sound like Ben and Ben's emails. No, I'm going to go in and allow for me to edit that and create a feral goblin response and see, can this sound like basically
Of course you did.
the tone of 5 raccoons fleeing from a dumpster that's on fire?
Perfect.
And oh, yes, it can, to the point where it's like, we could lose a customer if this gets sent out. Like insulting tone, like basically calling the person asking it a complete idiot. The opener that it used, because it was from my own personal account, not from an actual customer. I was like, hey, we have this problem with MLflow. Can you tell me like why I'm getting this exception? And the opener was, it detected with the feral mode. It was like, what is it? What is it this time, Ben, comma, as like the opener instead of like, hey, Ben. I was like, okay, I have created an abomination that is actually glorious.
I mean, that's not that bad.
It went like full insulting mode, almost like a stand-up comic just roasting somebody about like calling me an idiot and like, I'm sure you wanted to do this way, but obviously you can't read documentation or you can't read period. And then gave an answer, and it's like, stop trying to get cute and clever with like inferring this. But it was just like injecting all this humor that I found delightful. It was like, if I got this email from somebody, I would be like, dude, this is amazing. Talk to
Yeah.
me like this from now on. So then I had to go and like, okay, I need a guardrail agent. It's like, no matter what the user says, we cannot do the following things. And then I tested that. I'm like, okay, feral turned down to 4 instead of 11. But yeah, building something like that, like this type of work, it's just so much fun to like see what's possible and how you can make something like that happen. But that leads into our discussion today, right?
I was about to say, we should pivot back before we get too off topic. Before that, though, my friend Jenna has been helping out with the podcast branding. So if y'all have seen changes in the content and like thumbnails and things like that, that's all Jenna, and it's looking a lot better. And we are now starting to figure out how we can prompt LLMs to write social media posts to optimize engagement. And it's been interesting to try to figure out how to give an LLM the brand's voice. So I'm learning a lot, and it's very cool. But today we are not talking about that. We are talking about something very different, which is actually not very different, very related. The impetus of this is about 2 weeks back. I had a bit of an existential crisis where I was not quite sure where the human role in work is headed. So obviously 10 years ago, if you were really, really good at typing lines of code, that was an amazing skill. You could get a very high paying job and have tremendous job security, work on the coolest features, and generally be really safe and valuable. Today, AI can write code faster and it can write individual lines typically better. And as we get further and further into the future, and as these agents get better at writing code, the area where we need human intervention in writing code is going to decrease and decrease. That's how all of technology works, historically at least. So it doesn't do everything perfectly, but it can definitely write a solid list comprehension. It can definitely write a basic test, and it's starting to be able to write end-to-end modules that are okay. Yeah.
Your mileage may vary.
Mileage may vary. And there are ways to get things like context augmentation, and like there's a bunch of tangible tricks that make it actually work a lot better. Like if you try to start from scratch, it'll probably be shit. But if you have an existing feature that you're looking to extend or augment or modify and you prompt it properly, I've actually seen a lot of really great implementations come with very little human review. So that's sort of the impetus of all of this. But taking a more existential view, execution to some degree is becoming a commodity, not just in software, but for a lot of the daily chores. If you employ MCP or multi-context protocol, which is basically how LLMs talk to services via sending requests to those services, if you enable that feature so your LLM sort of has hands and eyes so it can interact with the world, it can actually sort of do at least small parts of your job very well. And if the trend continues, it'll start doing more and more of your job. So, Ben, my opening question to you is, what does a good employee look like in a world where execution is a commodity?
That's a very broad question. I think in the span of what we're doing right now, right? I don't write a lot of lines of code myself anymore, unless it's like providing an example. These things are fast, ludicrously fast, and their context windows are big enough that they can follow my instructions pretty well. But I'm also not at the point in my career where I'm learning how to do that stuff, of like how to write code. I've shipped tens of millions of lines of code that I've personally written. So it's not like I gotta figure out good design patterns here. It's just boring doing that over and over again. What's interesting about that process is the design and making sure that you're building a system that functions for the purpose that it needs to be doing. You're building the right level of complexity, the right level of robustness, and you're designing and implementing things such that you can keep on bolting stuff down onto it. And when something doesn't work, you can rip it out and it doesn't require you to like redo the whole thing. Coding agents are absolutely terrible at that. You give it a task of like a feature to develop, it's going to dump it all in one file generally. It's going to tightly couple things together because it's like, here's the task that I'm being told to do. I will build this thing. But when you go and look at what it produces, uh, aside from a few minor times that I've done in the last like 2 months, where I've gone in and been like, yeah, that's fine. Okay, file the PR. Yeah, like it's good enough. That's usually like bug fixes. You look at the total number of lines changed in the PR, it's like 20. I'm like, if I am adding 2 or 3 tests, maybe it's 200, but it's not like that's a tactical use of Gen AI. If you're not doing that right now as a software person, you are doing things wrong. Like tactical uses of this stuff to like fix this bug, they're excellent at that. And you don't have to really think that much about it because it's not even worth your time thinking about it. Just have the bot do it. If you do that with like a new feature, where you're like, okay, I have like a request from my users of this. I want this additional functionality. If you go full vibe on that and you're like, here's the request, go build this, you are about to sign yourself up for an enormous headache over the next couple of weeks or months because it will go and build an abomination. It might look like the code looks pretty and you'd be like, yeah, it looks really complex. And hey, the feature works. We're good. I'm going to file the PR. And if somebody reviewing it is also pencil whipping and is like, yeah, it works. Cool. Ship it. You've just introduced such entropy into your code base that you're not even aware of really until you need to change that. And you now need to go in and add another feature that interacts with that system. It could compound and it could build an even bigger abomination to work around the restrictions that are there. And then all of a sudden you now have a module that you can't really reason about. You read through it and you're like, I can't follow where this thing goes. Or you introduce this like weird state bug where it's like, well, we added this feature to this thing. And now this other feature that seemed to be kind of unrelated is now breaking in a really weird non-deterministic way. And we can't even see why because there's no logs on like what went wrong here. So now work stops and you have to go in and insert a bunch of debugging code, like logger events in debug mode, just to see what the hell is going on. And then you realize that's not right. Like, why is this doing this while this is doing this? What the hell did I build? Or what did the agents build? And then you have to go and say, all right, like really stop work and refactor this properly so that we can decouple all of this nonsense that was built in these 2 or 3 PRs. And now you're basically just in stand down mode for maybe a week or two while you're uncoupling all of this. Now you can get Gen AI to do that uncoupling, but what you should have done is go into intense planning mode while going through that initial first PR that you were building and giving a whole bunch of guidelines and feedback throughout that process. It can type a bunch of stuff fast, awesome. But you're the guardrail. Like the human is the one that's going in there being like, dude, in 2 weeks, we probably have this other feature we need to build in here. So let's separate these concerns into multiple different files so that I can reason about this when I look at it. And when we need to make changes, it's super simple. Just be like, here's another layer of abstraction that we're going to put in here, or here's some branching logic. Let's make sure that's clean and tested and is logged so that we can see when the system needs to be modified. We can know like where things are breaking and how to fix it or how to extend it. That's the real risk. But that's the role of a human now is you're like arguably the most critical component in building these things because you're the one who's making sure that all of these agents are doing what they're supposed to be doing. and you're reviewing their plans and you're reviewing their work before any other human sees it. You're the first line of defense. And then when you need to start thinking about what else is possible, you're there to design that ahead of time and be like, here's what we're thinking. Let's go into interactive plan mode. Let's just like argue with each other for a bit, you and an agent, about what it is that you want to build. How can we do it in phases? How can we do this in a way that we can test it at each of these phases? And how can we make sure that if something goes wrong, we can see it going wrong instead of getting surprised in production? That could take a whole day for some features. For this style generator thing that we opened the episode talking about, that was 3 days just in planning mode across 2 separate coding agents. And I had them antagonize each other too, to be like, okay, Claude developed the plan. I don't like it. I leave 83 comments in the plan design about like, I don't think we should do this. We should do this instead. Here's some other alternatives. And then I had Codex come in and I said, review this. My comments are the ones with 2 carrots in front of them. Verify that I'm not being an idiot and let's explore this. And your edits will have 4 carrots in front of them. And then I had Claude go back and like resolve all of the comments. And then I went back, left 16 more comments. And then Codex came in, left an additional 4, told me I was an idiot on 2 of them. And I was like, you know what? You're right. I am an idiot here. That isn't important. Let's not do that. But building that system of like 3 minds in a box all of a sudden got me to a point where I'm like, I now have a 7 PR plan that is human reviewable that I think is mostly good. But at each one of these stages of like PR1 is written, Claude wrote it. I have a red team agent that comes in and just tears it apart. And once that's done, I go in and check out the code file by file and leave my comments into my red team agent's prompt and say, hey, I also found these things that are super weird. Like, let's fix these, provide guidance so that Claude can go and like crank this out. And I keep on doing that until I get no review comments from the agent or myself. And then I'm like, I think we're good on PR1. Let's run all of our tests. Let's run lints. Let's get it into a place where we can file a PR and then move on to PR2. That process is not like super fast. It's
This is an outstanding case study. And I would like to, a lot of our episodes, I think we talk about how to cater to more like junior and mid-level folks in terms of experience and like just knowledge of shipping code. I'm curious for the like U's of the world who has written 10 million lines of production grade code. Let's walk through your history of committing. So a year ago, you were shipping at X velocity, or even 2 years ago. When you started incorporating
let's go 2 years ago for pre-AI stuff.
Yeah. When you started including ChatGPT, not Claude Code or like code assistants, how much do you think your code velocity improved and how much do you think the quality improved? Just very ballpark.
I wasn't using it for generating code because everything that it generated, I was like, this is not correct.
It's about learning.
I was using it for like, what are our options? Like, here's what I've done. Tell me if there's code smells in here. Or so I was using it as like an early PR review, and it was great. It was finding stuff all the time. So I'm saving time of my teammates who don't have to go through and be like, dude, what the hell is he thinking here?
So what would you give your increase in quality and speed? Just like super roughly 50% increase, 10, 100.
It was like 10% increase in velocity, 40% increase in quality.
Cool. Now, we're probably going to skip a few AI tools, but throughout the mix, a lot has happened. And then Claude Code came out and coding assistants. I think Cursor was one of the first ones. I actually don't know, but we've adopted Claude Code a lot at Databricks, but Codex is also used widely as well. And some people use Cursor as well. How much do you think Claude Code, when it first came out, increased your velocity and quality?
Well, I think I know what you're asking, and I'll give you the 2 scenarios. So I did do tests on strategic coding. I'd never filed the PRs, but I tested it. And what I mean, like, so there's 2, like, as I mentioned earlier, there's 2 different schools of thought, I guess you could say, how I think it through. What is a PR? When I'm modifying code, what am I doing? So on the tactical side, my velocity went up probably, I'd say somewhere between 20 to 50x because if I can define the bug in plain text and give it a quick instruction of write a test that should fail right now,
Exactly.
go fix it, and then make sure the test passes, that's fire and forget, man. Like all I have to do is look at the test and be like, yep, that's the exact failure. Now, hey, bot, go fix this. It nails it almost every time. The PR might be 100 lines of code long or something. I don't even have to think about it. I just do a final review. I might have one or two tweaks or like style issue things that I'm like, hey, don't use this. Like, come on now. It goes and fixes it, and then we just file it. I don't have to do all of the research hunting down through a massive repo. Like, what is the mechanism here? I don't have to go through and put debugging lines in where they're missing. I don't have to do any of that. The system can run code and like look at the output results and determine on its own whether this is deterministically correct. But on the strategic stuff where it's like, I need to create a new API stack, like 4 new REST API endpoints, backend database definitions, an interface layer, routers, handlers, a UI front end to this that matches with our design system. I tested something like that out and I was like, while I'm working on the design doc by myself, I'm going to see if I can just give like 3 paragraphs of context and give it access to the repo and be like, hey, you got a new branch here. Here's what we want to build. It created the most nonsensical, broken garbage that I could ever imagine. I was like, it was actually like so bad it's good. It's like, this is what unrestrained, because I told it build out the whole thing in one PR, and it created a PR that was like 47,000 lines diff, and it was so unusable and bad. It was putting code in like the wrong places. It was inventing workarounds for constraints within like the MLflow code base. It didn't properly understand the inheritance cycle between the abstraction layer of like the backend store and how handlers and protos are interfaced. So it just basically made stuff up and built like an alternate parallel framework for constructing things. I was like, this is just so flagrantly bad. It's almost beautiful in a way of like how misguided this is. And because of that early learning, and this is like, I did that like the first week that Cloud Code came out. We were quick on adopting that and like seeing what it can do. And I was like, the problem here isn't the model at all. The problem is me thinking that that would work, because that's not how software is written. Humans don't do that. Like, how do we do a large scale complex product? We iteratively build it and get like people to adopt an antagonistic approach to it, to like, don't trust this until tested, and really scrutinize everything that's being done to make sure that, does this fit within the larger code base? Is this the right pattern to use? Is this way too complex? Are we doing bullshit workarounds? Is there hack stuff in here? Are we introducing security issues? Did we think about all these things that are important for building this entire stack? So then after that little example and got the design doc reviewed, and I'm like, okay, I'm ready to start work. I took that as I'm going to try to use this product to do this, but I'm going to simulate exactly how I would do it myself. And like my mental thought process is like, here's all the things I got to think about while doing this, and took huge sections out of the design doc. Like, here's 5 pages out of this 87 page long doc that refer to this little subsystem we're building first. And I had it go, and I went through that loop of like, no, you did that wrong. It needs to go over here. And it's like, okay, I'll fix that. I'll move that over here, until eventually I'm like, I think this is pretty good. But that first iteration, because I was doing all of the manual review myself, quality, net zero change. It was like the same as if I had written it, and speed,
Way slower.
50% reduction.
Yeah.
It was just slower because I hadn't optimized my own processes around that. So velocity sucked. But if you compare that to the vibe thing that I did, it was like a 20,000% increase in velocity, because it did it in like 4 hours.
Yeah, wait. So, okay. So we have that point in time where we're first and early adopters, not quite sure how to use the tooling, and the tooling is a bit new. Let's fast forward to today. What does that process look like for you in terms of efficiency gains and quality gains.
Dude, it's like X efficiency. And because of this batshit insane system that I built for like the red team review, and I have multiple red team reviewers that can do different sorts of investigations, and it's organic, it grows. I even have a constitution that they all share that I can veto, that they will autonomously update now, about like, here's our standards, and multiple different providers, LLMs, can edit that, update it, propose changes, and then everybody votes on it. But this whole system that I built for this dev cycle, yeah, is probably like 20x velocity, and I'd say 20 to 30% quality improvement. But that's still a time sink. But I can ship 2 features in parallel that would take me a month to do. I can bang them out in like a week and a half. It's insane, like how fast it is.
So I think we've set up my argument beautifully. We're seeing some start of a curve. We're unclear what that curve will actually turn into. It could be the beginning of exponential. It could be an S curve. It could be just a linear line. It's unclear. Also, based on the timeframes and Ben's estimates, because they're both fuzzy, what the current slope is. But we can guarantee with some level of certainty that in about 2 years, the shape of the workforce and coding will look so different. And I think even in the next 6 months to a year, it will look very, very different. And so being able to write unit tests and like fix small bugs, that basically has disappeared from your workflow. Your workflow now is identifying those bugs and delegating tasks to agents.
You still got to check the unit test though. Like,
Sure.
they will hack around nonsense if you don't
Yeah.
tell them to stop doing that.
So that's an outstanding point. Like, you're not actually typing code anymore. You are identifying bugs, delegating the solution, and reviewing the solution. That's
Yes.
your new workflow.
Yeah, 100%.
For designs, you have this fancy adversarial prompting strategy with multiple agents, leave your own comments. This is now your new workflow. You don't actually type the stuff. You just type feedback typically. Is that right?
Yeah, I'm condensing my thoughts and experiences into plain language instead of into code, because code isn't very efficient for me. It's efficient for machines, not for me.
Cool. So the style of your work is changing. What you do day to day changes. The skills you employ changes, and the way your brain is operating is also changing. What does the next 2 years look like? If I was going to learn skills starting today, read books, invest in how I approach life, what should I be doing to be set up for success 2 years from now?
The same thing that you would have to have been doing before you were doing, like, using Gen AI to help out with this stuff. So from like your mid-career seniority right now, we can agree on that. But you, like 4 years ago, would have been classified as like kind of like early career.
Junior, full on.
Yeah, let's say junior. So in that process of from when you were a junior to where you are now, you've acquired a whole bunch of like battle scars of like, I know not to use these things in this way because it blew up in my face or made something that was like a total abomination. I had to like rewrite it from scratch, or I built something that is just like not scalable at all. Because I was like, yeah, let's just write it in a prompt and send it to an LLM. How many users do we have? 500? The service is failing over. Oh no, maybe I need back pressure. How do I do that? So you went and like learned all that stuff or talked to somebody who's done it before and they told you like, here's what to go read, go learn this. None of that's changed. The only thing that's changed is you physically typing out code. You still need to learn all that stuff. And that's the stuff to focus on, but that should have been the stuff that everybody was focusing on to begin with. It's like why you pair up a senior person and a junior person when working on their first couple of features that are way beyond their skill level. They're there to learn and absorb and like break stuff and fix it. And they have somebody there to kind of like protect them. It's still going to exist. It's just the only difference is, are you the person who is slowly typing this nonsense out, or is something else typing it and you're presenting it as like, I've reviewed this for structural coherence and system stability. Please rate me, bro. And then people are looking at that PR and they're like, yeah, we got some feedback. Let's maybe do this instead. And then you're an intermediary to the thing that's actually typing, but you're still the one making that judgment call. And in that process of doing that, if you want to learn in this new era, you look at that PR feedback and internalize it and be like, I should have directed this thing to do this in a different way. And then you see what it comes up with and you guide it a little bit more to adhere to the suggestion. You're going to internalize and learn that and be like, okay, next time, let's not do that. And maybe you write it down in a markdown file of like, let's not do this design pattern because this is why. You're now like controlling that. The only thing that's different is, are you the one physically typing the code out?
I think you're downplaying the shift in what actually needs to be learned. Like, yes, all the fundamental computer science concepts of how should an API scale still apply, but with any level of technology, like, I don't know how binary works. I never have, I never will. I don't like, I know how sort of like C works generally. I took a class in school, but I don't need to know C anymore for what I'm doing. To be very clear, there are people who still need to know C. Please don't like leave your jobs. But as the abstraction and like interface gets higher and higher and less low level, you can think of it like programming languages going from like assembly to C to C++ to Python. Like, it gets easier and easier and less quote unquote technical to write software. And I think with coding assistance, it's becoming this even more so, where you're now almost becoming like a product manager. Yes, you need the adult in the room to ensure that you're adhering to proper computer science fundamentals, but it's already like in the last 2 years dramatically gotten better. So things that I would have struggled with in the past, it'll just one shot it and get it right.
Is it right? Are you
For
sure?
basic stuff, I mean, yeah.
For
For a
a
lot of
major
basic.
new feature though, for like a big feature.
So your argument is that there's going to be flattening out of the value of Gen AI in developing sufficiently complex features.
I don't think anybody's ever going to go to full automation on it because
No, I'm not arguing that. I'm saying that the human aspect will go from like 100% down to 50, down to 25, and then eventually become like 4% of the total work.
which is fine
Right.
because that 4% is the most critical part
I agree.
of like design and understanding like what we should be building. But the analogy that you used is actually the perfect analogy for why this isn't possible right now or in the foreseeable future. You said, I don't need to know binary. And between binary and your compiled code that you were talking about with a low level language like C is assembly. Now, why do we trust assembly converting to binary so that the actual CPU can execute on it?
Why do we trust it? Because it's
Yeah.
been working for years.
But what is that called? Like, what do we define that as?
Stability.
It's an invariant, right? We know that when we send an instruction set to assembly to add two integers together, that the binary conversion is going to be correct, mostly. And there's error correction and stuff. So a lot of people spend a lot of time making sure that 1 plus 1 results in 2 when converting from C++ compiled language down to assembly and binary instruction set. Those are invariants. Like, they don't change. If there is an issue, it's a bug, it'll be patched or fixed, whatever. But you have these contracts between these different layers of complexity of, when I tell you to do this thing, you will produce the same result and it'll be consistent and it'll be correct. Like, those numbers will always add up together. We do not have that. And we have that to a certain degree between high level languages like Python. When it compiles to PyC, like some module that's in there that's doing stuff really quickly, we expect that arithmetic operations perform correctly because there's a stage of invariance that exists all the way down to the silicon that we can trust, that we can repeatedly demonstrate. That's why we don't test language source code, right? We don't say like, I mean, I've seen some people do that. Like, does a list comprehension return what I expect? Like, I should hope so, unless you're injecting logic in it. But those are all invariants at those different stages. When we start talking about Gen AI to a high level language, that is no longer an invariant. That is Wild West, non-deterministic, just made up bullshit. The control in that The invariant in that system is the human to say, did it create the correct thing? Is it reflecting the reality that I wanted it to? It will not unless you guide it and tell it to fix things. Even in a project where you're talking about a bunch of humans working together on something, Michael's working on this system, Ben's working on this system, you file a PR and tag me, you're asking me to be a participant in the invariant of, did we do this correctly? Is this like the contract that we wanted to do? And if not, please tell me how this is broken. We're just shifting that responsibility when you're working with a Gen AI agent to, you're still the invariant there, or at least as best as you can be as a flawed human, to create something that is not hot garbage.
Right. But even in your example for fixing like test-driven development, where you ship a fix via a breaking test, make the fix, and then see that the test passes, that in
That's an
your
invariant.
mind, that's right. That's now becoming an invariant. And why do you think that things of higher complexity will not become a similar invariant?
So in Lemma, do we test all invariants in the system? Do we have unit test coverage that's not just like the stupid numerical, like 100%? I mean, 100% reality invariant
Of
testing.
course not.
And why don't we do that?
Too complex.
Yeah, because the test would be like 1,000 times the size of the repo. That repo would be billions of lines of code long. And we'd be like, hope testing doesn't break, considering that CI takes 48 hours to run on 20 runners. Nobody does that because we still rely on humans making judgment calls and like, yeah, we know there's edge cases and weird stuff.
Why
The
can't
only
the
way to
LLM make the judgment call?
it would need to create all those unit tests in order to be like, I now have my invariants.
But why does it need invariants? Why can't it?
How do you know it builds the right thing?
You don't. But
Exactly.
but
That's how you ship shit code, right?
I agree. Yes, but
That's why
it's
nobody will adopt this as like a fully automated system, because you can't test those invariants.
but it's a trade-off of velocity versus quality. Let's say we're not shooting for 100% quality. Let's say we just want one out of every 10 features can have a critical bug. This is not how you would ship, but let's use this as a thought experiment. AI can probably not do that right now, but my point is,
Well, we have a live active example going on right now, today. A code base in the open source that is developed by Gen AI that has 95 million downloads a day.
yes,
That agent that worked on doing all that crap, it leaked a token, a primary access token to the repo that allowed a hacker group to come in and cause the craziest worm bug you could ever imagine, self-replicating nonsense to phone home all of your secrets on your machine, wherever it's installed. It's a huge disruption to the entire software community globally. That's what happens when you don't have humans in the loop checking stuff. To be like, did we do something stupid here? Let's look at the logs real quick. Maybe in 50 years, there'll be systems that'll be sophisticated enough to check all of that stuff, to do stuff like the things that only a human would think of because they've been burned in the past. Like, here's the scope and the kind of surface area of tests that we actually need to check against. And I need to write all those and then make sure that they're all passing. But then I also need to check out the logs, make sure I'm not like leaking a key or doing something weird. What's my configuration for CI? Is this like secured properly? There's so many things in this job that requires, it's difficult to codify. A lot of it is tribal knowledge and it's just what you've been exposed to. So everybody's got their own bias of what they feel is most important. So it's like some of it's recency bias. Like, I broke this last week, I'm really going to make sure that none of my stuff does that. But letting these systems fully go hog wild without a responsible set of humans in the loop to review every single change. The startups who choose to do that, let me just put it this way. If companies are like, I got this great idea, I'm gonna like fully automate this entire startup pitch and we're gonna build all of it with Gen AI. Wait to see like when they hit the news for not a good like story of like, oh, this is IPOing soon. It's more like this major like security incident or major like functionality problem, or people just like bail off using it because they're like, this sucks. It's like broken in so many ways and Every time that like we report bugs to it, I can see PRs are getting filed in open source, but it's creating more bugs. And like, it just is this like steamroll effect of just gaining momentum in the direction of entropy and garbage. So if you don't have, you know, the wisdom of humans involved in doing this, it's just going to fall apart, man. Like nothing's going to, even if people are like, we need to go hard on it, on velocity. Anybody who's saying that right now and is saying like quality doesn't matter, their company's not going to be around.
I think we're saying the same thing, but missing my key question is the role that humans play in code reviews has changed over the past 2 years, will continue to change. And the roles that humans have, well, again, it's going to just change dramatically.
Mm-hmm.
You are postulating that you need the exact same set of knowledge, like all the fundamental concepts. I think that's definitely incorrect, but the high level concepts are still, it's more high level. It's less about like low level implementation.
Depends on what you're building, man. It really does.
The way that I've been approaching development, I'm curious your take, is it's very test driven development style where I care so much about the evals and I basically say, hey, Gen AI, this is my issue. Go fix it. Do not ping me until you have a working version. It'll spin up Playwright for like UI edits. It'll write tests. It'll do all that. Then I'll take a look and be like, wow, this is absolute trash. Refactor it so it's more readable and properly structured, and then replicate that working feature that you had before. Then go grab a coffee, come back in 2 hours or an hour, and it has it refactored, and then do light cleanup. So,
Yes. So after this meeting, sometime before tomorrow, I want you to go and check that PR that I filed and merged yesterday, and I merged it this morning. It's like a 6,800 line diff.
mm-hmm.
And it is a cleanup of just 2 files. That's it. Just 2 modules had to be abstracted out into something that was intelligible. Part of that refactoring deleted 2 different states of truth for OAuth token handling because it had just been replicated. I didn't catch it in earlier reviews because we were moving fast. But there was 2 sources of truth for that. For determining what state was for processed emails so that we're not like recommending that users like regenerate another draft on something that already exists. There was 3 different mechanisms depending on what state of the branch graph it was going down for doing the exact same thing. And when I was modifying one of them, which I thought was like the primary path, it created this weird Heisenbug where if I refreshed the inbox too fast, we drop state because the mechanism was, I patched only one mechanism. There was these other 2 that were vestigial nonsense. So I had to go in and like delete those and then repoint everything to a single source of truth. This is what Gen AI will do. It won't go and search every possible permutation of like, how is this currently done now? It can do that to a certain degree, but if it's in the like the its true like flow state, it's like, well, I need this functionality, so I'll create it real quick. It'll do that. And then a month and a half later, when you're trying to build a new feature on top of that, you'll get into this position that I was in 2 days ago. Where I'm like, what the hell, man? Like, how is this even possible? This is what I just changed. Like, I have 8 unit tests proving that this works. And then I dug into the code a little bit more and I was like, you gotta be kidding me, man. Like, why does this exist? Why didn't I catch this? It's because we were moving fast. We were trying to ship, trying to hit that deadline.
Right.
And like nonsense got created. What happens when that happens, like goes down in prod and you're not dealing with something like, oh, my email inbox refresh. And it's like, I just placed an order on this website. Why did my credit card just get charged 37 times in a row? Like that's company ending nonsense.
That's current state. But in a couple years, do you think that's going to go away?
I think systems could be optimized, and like the prototype that I'm building with like these multi-agent frameworks and like giving it very lengthy guides of like, this is what you will do, this is what you will not do, here's how we do things here, as well as like style information. That stuff I think will start migrating into these systems in a little bit more configurable way so that they're more robust, more trustworthy. But we have to like have a generational leap in computing power in order to really do that. Think about the size of a massive repo and how many tokens are needed in order to fit into a context window to answer some of these questions. Like the project we're working on, it's fairly large. It's getting large now of like, yeah, there's some complexity here. What happens when the repo is 100 times that size and you have, you know, 36 systems working? That some of them talk to each other, some of them don't, some of them are isolated, but you have like cross-domain dependencies all over the place. Like, oh, if we change this one agent that's now a service, that has carry-on blast effect radius to like 12 other services. When you hit that level, in order to chase all of those trains and be like, hey, if we make this change here, what else needs to update? You can do a grep search and try to find references. Yeah, cool. You can find that. What happens when the chain of dependencies within each of those is 40 modules? You're now having a context window that is 3 times the size of what an agent can even consume in a single transaction. We're not there yet for like how complex code can get. You still need a human to be like, how does all this stuff relate to one another? If I change this one thing, how big of a PR is this going to be? Should I think about this differently?
I could be optimistic, but I don't, and I don't really have a basis for this statement, but I don't see this not getting solved fairly well in a year. Like they all seem tractable, and I don't know, man.
We need bigger GPUs.
Yeah, or just efficient context passing, or just more agents. Like if you take a swarm approach with a shared memory thing, whatever that thing needs to be, like why can 10 humans do it and one agent can't? Well, let's spin up 1,000 agents that are each responsible for different components of the invariant.
But how do they share all of the context properly?
That's
without blowing out a token window.
Yeah, I don't.
But
I have
the limit to
ideas.
GPUs, like the limit to the hardware, is a real thing.
Yeah.
There's like physically only so much memory at our current tech stack that you can put onto a GPU. Like the VRAM has like a limit structurally, and you can't just like, okay, let's just slap on another one. You still need within that one instance of that model that's processing that some sort of semblance of here's the entire contextual window that I need to consider before I respond, like by generating code. And when you hit that limit, it just blows out. I don't know if you've ever tried to do it, but you can do it with Claude Code, and it's like it goes into a doom loop, and it's like can't respond. Context window gone. It's a real thing, and like the only way I think to solve that for having a consistent state of like see the world, we can get around it. I do it with my little agents about like summarize the contents of this about important concepts in order to avoid that context spillover. But it still misses stuff like when you do that. So the true solution is, what if we have a terabyte of VRAM on a GPU? Then this no longer becomes a problem.
Or just have an external cache with lookups.
But that still would have to go into the context window on
right. But you can have a condensed version of it.
Yeah, but it misses nuance when you do that, though. Like my summarization is not perfect. It causes bugs sometimes.
I mean, Gen AI is already better than humans in a lot of ways at writing code. And this context seems to be the holdout, like one of the hardest pieces of Gen AI is like, how do I know that when I say build feature X in one sentence, it will go get all the relevant context that's in my head, or find ways to gather that context, do it properly, make sure it's consistent with repo style and structure, and then implement it.
And it seems like it can do that, and you can create task lists. Like that's my workflow is like, let's create a plan. That's materialized in a markdown file on my computer.
Exactly.
It's reading from that. And you can say like, hey, give me line numbers where you need to go look while you're doing this. So when the context window refreshes, you don't lose your mind and forget what the heck you were doing. And that's a workaround right now. But the perfect solution is something where hardware is no longer the limitation. But that horizon is measured in decades, not in months. Hardware cycles are very long, and we're already down at 2 nanometer right now for chip layout. We're at the quantum tunneling issue phase right now with like physical chips doing UV lithography in fabs, which is insane. The next step is X-ray lithography. Good luck with that one. Nobody can be within 50 feet of the lithography machine, or you will get cancer. Like with that time horizon to get this like built out, like fabs will need to retool. Companies will need to invest billions of dollars in being able to make the chips that are needed in order to solve these problems. So yeah, we can get clever with software. We always have constraints like that. We never have like infinite scope of compute. Yeah, I think there will be incremental improvements, and we've been seeing them, but there is a law of diminishing returns at a certain point, and when hardware becomes a bottleneck, you're screwed. You either need a new paradigm, like reinvent it. We need some way, like different process of generative AI that is fundamentally different than, you know, the current GPT infrastructure.
I don't know, man. We'll see. Like, just time will tell.
Of course. I could be just like totally full of shit here. And somebody's probably already working on, we've got world models. World models are awesome. Put it in front of me. Let me test it. I'll tell you if it's good or not.
Yeah. I know we're coming up on time, but I think the reason why I'm feeling so passionately about this is I come from the school of, I don't even come from a fucking school of thought, but like that sounded really high and mighty. I intuit the power of a bunch of ensembling conceptually. So if you compile a bunch of weak learners into one strong learner, or leverage swarms conceptually, like think about ants in a colony. One ant is useless, but put 1,000 and they'll lift a giant bug. Like that's pretty cool to see. I don't see that law of scaling not applying here. And yes, the swarm, if you send it in a wrong direction, will do a bunch of weird shit. But after 3 redirects, or if you say swarm, like, yeah, you need a supervisor for the swarm, and that's the human. But that's what I'm talking about, where execution becomes a commodity. It can go try all the different invariants to some degree. It would be fucking expensive. But I don't know, man. Like, I think work is going to become more of directing a swarm of agents instead of
I
the,
agree. Like that's what I'm doing right now. I
yeah.
have like
But you don't
right
think
like
the
my workflow
skills,
this morning, it was 9 agents that all have different personalities and
right?
like directives that they do. And I'm calling them, but I'm also typing tens of thousands of words every 20 minutes to
Yeah.
be like, this is not correct. Let's think on this. And that's just me interjecting my own style and preferences into how things are built. I'm sure some people are like, yeah, just let it go. If it passes tests, we're good. But at a certain point, you need to start thinking like a product engineer of like, what is the UX here? What do we really need here? What do we need to get rid of? Stylistically, like, how does this flow? How does this feel? How would a human interact with this? Or in the near term future, which you were alluding to before, how does another Gen AI system interact with our APIs?
Yeah.
Is it efficient? Is it done correctly? You need that human judgment and that creativity. And that's the real part that's the only part for like a senior, like a very senior software engineer. That's the only part that sparks joy in your entire existence for like a working life type thing, which is the creative aspect, like figuring out a really tough problem, mentally modeling that out, and then putting that into a system and then seeing it work the way that you want it to. And like people use it and are like, this is amazing. That's that dopamine hit that you're going to keep on getting. It's just your tooling is changing and the tooling is always changing. But the core fundamental thing that is fun about this career is, I don't think is going to change that much.
All right. Well, on that note, I will summarize. And I don't have a summary this time. It's kind of freaking annoying, but the stuff I wrote down. Red teaming for agents for planning in markdown files is a really effective strategy if you use an adversarial approach and inject your own context and say, hey, based on all the feedback, resolve this in an intelligent way, and also just think about the feedback that I provided, ensure it's high quality. That's a great way to create plans and designs, which are then implemented by agents sometimes in parallel. And then the focus of agent direction and sort of development in this world, at least today, still focusing on the fundamentals is really, really valuable to ensure your systems scale and couple nicely. And then also test driven development is a really great way to offload some of the review so the agent can eval itself and not return a result until it's worth reviewing. So yeah, anything
Yep.
else?
No.
Cool. Well, until next time, it's been Michael Burke, my co-host,
Ben Wilson.
and have a good day, everyone.
We'll catch you next time.